It's me, Professor B, and we are going to talk about function transformations. This is going to be a series of videos that I'm going to do because I am going to break down a lot of the common parent functions for you guys and show you how they can be transformed, okay? So this first video is very much just an introduction to the idea of transforming functions, okay? When we say that, we're talking about shifting this up, down, right, left, stretching it, compressing it, reflections, all of that good stuff, all right? So we're going to talk about just some basic stuff first, and then in the next video, I'll start going over specifics. Just to give you an idea, these are the parent functions that I will be going over. If you guys think of an extra one that you want, or there's something on here that you don't see, send me a comment, leave a comment, let me know what you want, and I can whip up that video for you. Okay. Also, bear in mind, because we've talked about inverses before, these two are inverses of each other, which means they reflect across that y equals x line. Okay, they reflect across a diagonal line. These two guys are also inverses of each other, and these two guys are inverses of each other. Okay, so that those are related in different ways, but we're going to talk about transformations first. Okay, so we can describe transformations just by the way a function looks. All right. F of x is going to be our parent function. Later on in the series, I'm going to change this to P of x for parent, okay? And that's where we're going to start all of our transformations, all right? So the first thing that we're going to talk about is we are going to talk about vertical shifts. That means we are shifting up or shifting down, okay? And the one thing I want you to remember about vertical shift is your y's never lie. All right. If you see something, it is just as you see it. There's nothing extra that you have to do with it. Okay. And what you want to remember is that you will have some function, and we'll talk about what those different functions can be. Some function plus a constant. Okay. Any number. All right. Positive, any number, decimal, fraction, anything like that. So if we add a number, okay, to that function, that means we are going to shift up that many units, whatever C is, okay? And I gave you a little bit of an example. I said, okay, if you've got f of x is f of x plus 2, so that means that we are going to shift our entire picture, whatever the picture looks like, okay? We're going to shift that entire picture up 2 units, okay? That also means we would add 2 to whatever our y value is. So if our y value happened to be, let's give another example here. If your y value was started off as 0, 0, that means when you shift it up the 2 units, you are now going to be, that point just moved to 0, 2. Just the y value got moved. The x value is not being moved right now. You're only talking about vertical up and down. Okay? Well, what happens if you're subtracting? Same thing. You've got f of x minus c. All right. So we are talking, remember, f of x is also kind of a fancy way of writing y. That means we're going to shift down c units. When you're subtracting, you think you're going down, right? So we're going to shift down however many c is. All right. And the example that I have for this one, I have f of x minus 1. All right. So that means I'm going to shift the entire picture, again, whatever that picture looks like, down 1 unit. All right. And for your coordinates, you would subtract 1 from your y value. So again, if I give you an example of this one, let's say, oh, let's go complicated. Let's say that this guy, they have a point at 2, 7. That means that I'm going to shift down 1 unit. So the 2 stays the same, but the 7 is going to subtract 1. So it's going to go to 6. Okay. Again, this is not talking about horizontal at all, so we're not touching our x value. We are only shifting our y values down 1. Okay. That is your explanation of vertical shifts, shifting up and shifting down. Okay. Again, I'm just going over the basics in this video. I will do specific examples of different parent functions in another video, so stay tuned for those, okay? The next one we are going to talk about is the horizontal shifts. So now we are going to play with the x value, but we're going to leave the y value alone. So horizontal, we are shifting left and right. All right. So what I want you to remember about this one, for vertical, I told you your y's never lie. For horizontal, I want you to think about how your x's are crazy. They do the exact opposite of what you think they're going to do. Okay? They are crazy. So if we take a look at the first one, we are f of, notice where the plus c is this time. It is inside with the x value, with that independent variable. That's how we know we're shifting left and right. All right? But ordinarily, when we think about a number line, if you think about a number line, right? If we are adding, so here's 0, if we're adding, we think we're going to go in the positive direction, usually. This is where I tell you your x's are crazy. You're not going to be adding. You are going to be moving to the left. You're actually going to be subtracting. Okay? And it's still whatever the c units are. So I have an example of this one. I have f of x plus 1. All right? Plus, again, it's opposite of what you think. We're going to move to the left 1 unit. So we're going to shift backwards 1 unit. That means we are subtracting 1 from our x value. All right. So just like I did for the y's, I'll give you an example of this one. Let's say that we are starting at -1, 0. All right. The x's are what is being changed here. That's why it's a horizontal shift. So that is going to shift now to -2, 0, because I told you it's going to move 1 unit to the left. 1 unit to the left would be -2 from -1. Okay, so that's moving that way. All right. But now what if we're subtracting a c? So here we have f of x minus c. All right. Again, your x's are crazy. So even though you think minus, you think we're going to go to the left, we're not. We're going to move to the right. So we're going to go to the right however many c units we have. All right. In this case, I have f of x minus 8. That means I'm going to be shifting to the right 8 units. All right. And that means I'm going to be adding 8 to my x values. So given an example of this one, let's say I have, let's stick with the same thing. Let's say I have 0 or -1, 0. All right. And what I'm going to do is I'm going to add 8. Since even though it says subtract, I'm really going to add 8. So this is going to be -1 plus 8. So that moves to 7. The y value does not change. So that is examples of horizontal shifts. So we've covered vertical shifts up and down. Notice where the C is. So for a vertical shift, again, for the vertical shift, the plus C is outside of that parentheses. It is acting upon the entire function. The horizontal shift, it would be inside parentheses, and it is acting upon that x, that independent variable. So next, we're going to talk about vertical stretching and shrinking. Again, your y's never lie. So these are going to be factors. You are multiplying now. When you're shifting up, down, right, left, you're either adding or subtracting. But if you are stretching or shrinking, that means that you are going to be multiplying. Since it's vertical, we're going to be multiplying times the entire function. So it'd be some constant times the function. And you've got a couple of rules you want to remember here. If your C is bigger than 1, then you are going to stretch by a factor of that number. Okay. So think about if you stretch something, it gets taller and thinner. That's what you're going to kind of look like. Okay, but you're really stretching all of those y values. So you're multiplying those y values by whatever that is. If your C is in between 0 and 1, think about a decimal between 0 and 1 or a fraction between 0 and 1. You are shrinking, so you're squishing down all of your y values by a factor of, again, whatever that C is. So For your examples here, I have 3 times our f of x. That means that we are going to be a vertical stretch by a factor of 3. Again, the 3 is outside, so it is attacking the entire function. And that means we're going to multiply all of our y values by 3. So for your example, let's do 0, 4 for our point. So if we start at 0, 4, when we stretch this function by a factor of 3, now we're going to have 0, 12, 4 times 3. So that whole point just stretched up big time. Again, we're not doing anything to our x values, so that stays the same. When I show later examples of this, I'll show you what can happen when you are doing multiple things to a function. But for right now, we're just taking it a piece at a time. If we have the example of 0.7 times our function, that is a decimal that is less than 1. So we are going to be shrinking this down. Okay, it's going to be less than. So it is a shrink by a factor of 0.7. Okay, we're squishing it down. That means we're going to multiply our y values by the 0.7. So if we take that same point that we did earlier, we have 0, 4, and what I'm going to do is I'm going to multiply that 4 by 0.7. That means now we're going to have 0, 2.8. So we cut it down. Okay, we cut it down from 4 to a 2.8. All right. So that's your examples of a vertical stretch and shrink. Your y's never lie, so whatever's being multiplied times your function, that's what you're going to multiply your y values by. Just know that if it is greater than 1, that means we're going to stretch everything up. And if it's less than 1 but bigger than 0, we're going to squish everything down. We'll talk about what happens when we get into the negatives here soon. Okay? Next thing, we've got horizontal stretch and shrink. Again, your x's are crazy. Your x's do the opposite of what you tell them to do. So that's the exact same way that our functions work as well. All right, notice the placement of the c this time. It is inside the parentheses. It is acting upon that independent variable, that x value. All right, and we are in opposite land. So if your c is greater than 1, this is actually a shrink by a factor of c. Okay. If your c is between 0 and 1, that's a stretch by a factor of c. So it's opposite of what you think it is. For our examples, I have f of 2x. The 2 is acting upon the x. It's kind of inside those parentheses. So this is a horizontal shrink by a factor of 2. All right. And since our x's are crazy, we have to do the opposite of what it says. So instead of multiplying by 2, we're really going to divide by 2. So that means that if we start off with a point that is, let's say we have the point 2, 0, we're going to take our x value and we're going to divide it by 2. 2 divided by 2 is 1. Our y values don't change. If the number is less than 1 but greater than 0, that is going to be our horizontal stretch by a factor of 2/3. That means we're going to do the opposite. So we're going to multiply by 3 halves. Okay, we are multiplying by the reciprocal. So I'm going to once again start with 2, 0. But if we multiply by 3 halves, that ends up being 3, 0. So we're stretching it up. Okay. That is horizontal stretch and shrink. We have 2 more things we got to go over. We got to go over reflection, and we can reflect over the x-axis or the y-axis. Okay. Vertical reflection and horizontal reflection, I've got them both sitting up here. So for vertical, your y's never lie again. Again, you're going to have that negative sign. Now's where your negatives pop up. So if you ever see that negative sign, think of that as a reflection, okay? So we're going to multiply that negative times our whole function, that's times our y values. That is a reflection over the x-axis. So it's as if you were to take your graph and fold it over that horizontal x-axis, okay? That's where your new points would pop up. You're going to multiply your y values by -1. So for your example, if we have 3, -2 for our point, we're going to multiply our y value by a -1, and we end up with 3 +2, because -2 times -1, okay? That is our vertical reflection. For our horizontal reflection, we still want to remember that our x's are crazy, but in this particular case, it still is multiplying by a -1, dividing by a -1. Those are the same thing. Those mean or end up with the same thing. So do notice where the negative sign is in this one. It is inside. That means it's acting upon the x. So this will be a reflection over the y-axis. So instead of folding it over that x-axis like we did for vertical, we're going to fold it over the y-axis, and it changes all of those signs. So if I'm going to take the same point I did earlier, I have 3, -2. I'm going to multiply my x value by a -1, and that point will become -3, -2. Okay? That is just a basic coverage over what transformations can do. Like I said, this is going to be an entire series now, so I am going to go through a bunch of parent functions. I'm going to go through all of these guys to cover what those transformations end up looking like. Okay? Uh, Leave a comment, like the video, subscribe, let me know if there's anything specific you want to see, and I will see you guys in class next time. Bye.